Now coming to the next activity. Okay, consider two types of liquids. Let's say ink and honey. Right. Now, let's say you put the ink in one glass of water and then put the honey in another glass of water. Now, what you will observe here is the intermixing. Okay, intermixing of ink is faster in water than intermixing of honey in um, water. Okay, now why is this? See, this is because ink and honey, they also have got particles. Okay, they have particles, but in case of ink, okay, in case of ink, the particles are much faster, right? And in case of honey, the um, particles are much slower, right? That is the reason why ink gets the intermixing of ink is much faster, and it is much slower in the case of honey, right? Now, so from this activity, we can infer that different kinds of matter, okay, have particles moving with different amounts of speed, right? Now, coming down to the next activity again. Now, in this case, consider two glasses of water where you have hot water in the first, no, in one, and then you have cold water in one. Okay. Now, put potassium permanganate in both. Right. Now, what you'll observe here is the intermixing in hot water. Okay. Intermixing in hot water is faster than in cold water. Okay. So, right. Now, see, this is because in hot water, okay, there's heat involved. Okay. Now, if you consider this, heat is nothing but a form of energy, right? So consider this, okay? This is your glass of hot water. Now you have put, this is your hot water. Now you have potassium permanganate crystals, okay? Now, these are moving in random directions, okay? These particles. Now, there's heat. Now, this heat energy will be absorbed by the particles of the potassium permanganate, and once, okay, absorbed, okay, and once absorbed, this absorbed part heat, absorbed energy, okay, will be converted into kinetic energy, right? Now, kinetic energy is nothing but the energy due due to motion, right? So the speed of the um, particles increases. Okay, so now in the previous activity we came across that if the speed of the particles increases, then the speed of intermixing will increase, right? Okay, so that is why in hot water the intermixing of potassium permanganate and water is much faster. Okay, uh, compared to the cold water, right? Now here's the thing. See, since particles of matter are continuously moving, they will have kinetic energy, right? Now, when heat is involved, that heat will be converted into kinetic energy, so the kinetic energy will increase. Here's the thing. When the temperature increases, okay, when there's temperature increase, then this is, let's say, temperature, okay, then this will lead to increase in kinetic energy. Okay, now kinetic energy increase means the speed of the particles is increasing, right? Now if the speed of the particles increase, then the rate of intermixing also increases. Intermixing also increases, right? So that is it. Now coming to the next topic, that is particles of matter attract each other. Now just consider this example. Regarding this topic, you have three activities. Okay, we'll just go through the activities 1.7 and 1.8, right? And before that, I'll give you an example. Now here, I have a pen in my hand, okay? And this is a metal pen. Now if I try to bend it, okay, it won't even um, budge, right? So there is something that is trying to keep this pen together. Okay, now just consider, visualize it this way, that this pen is also a matter. So just think that this pen is also made up of particles. Okay, now when I try to bend it, there's something trying to keep this pen together. So what is that something, right? Now that something is nothing but intermolecular forces of attraction. Okay, intermolecular forces of attraction. Now these intermolecular forces of attraction, they are responsible for keeping the particles together. Now the greater the magnitude of the intermolecular forces of attraction, the harder the substance will be. Now I showed you, I told you something about this pen now. So this won't even bend. So forget about this. Now come, bring this scale now. Okay, this scale will bend. Okay, on applying the same force, this um, scale will bend. Now that means that the intermolecular forces of attraction in the particles of this pen is much more than the intermolecular forces of attraction in the particles of this scale, right? So the more the intermolecular forces of attraction in matter, okay, the harder the matter is. Okay, now so from this activity, we can say that um, the intermolecular forces of attraction, the magnitude of the intermolecular forces of attraction varies from one kind of matter to another kind of matter. That means the intermolecular forces of attraction are not the same in all kinds of matter. Okay. Now, coming to the next activity. Okay. Uh, open a water tap, try breaking the stream of water with your fingers. Were you able to cut the stream of water here? Now, when you take the case of water, okay, see, in water, the molecules have spaces in between them, right? That means they are not tightly packed. Okay, so again, that in turn implies that the intermolecular forces of attraction, okay, in between these two particles, these two particles, these two particles, they are comparatively very weak, right? And so, because the intermolecular forces of attraction are very weak, you can just overcome those um, forces of attraction uh, without any effort, right? That is the reason why you can cut um, through the water uh, with your fingers effortlessly, right? Just consider it this way: you can dip your hands into the sand and then just pull it out. Okay, so it's just like the molecules of no the particles of water. They behave just like as the particles of sand. Okay, they are loosely packed, right? So that's it. Okay.